Look at our sun. It is blindingly, almost violently bright. Yet, the moment you look away, space immediately drops into a pitch-black void. While it sounds like a simple question, the answer reveals a set of physical rules that challenge our basic assumptions about how the cosmos works. We often view this darkness as a simple absence of light, yet it serves as direct evidence that the universe is behaving in ways we never expected. Consider the sheer scale of the universe. There are billions of trillions of stars out there, many of which dwarf our own sun in both size and intensity. Imagine standing in a massive forest. In every direction, your line of sight eventually hits a tree. The universe should operate exactly the same way. If space is infinite and packed with stars, every possible sightline must eventually intersect a star. Mathematically, there should be no dark patches. The entire night sky should be a solid, glowing wall of blinding white light. People often assume the sky is black because space is empty, but that explanation fails to account for the actual physics at play. Light from infinite stars is constantly bombarding us from all sides. To find out why we can't see it, we have to look at the physical mechanics of light itself. Here is the first rule of optics. A beam of light is invisible to the eye until it crashes into a physical object. On Earth, the glowing daytime sky is manufactured by sunlight crashing into microscopic oxygen and nitrogen molecules in our atmosphere, scattering in every direction. In deep space, however, you have a pure vacuum. There is no air, dust, or gas to intercept that traveling light. Without matter to bounce off of, the light beam stays dark and undetected until it directly strikes a receptor, like your eye. Earth's bright sky is a local phenomenon caused by atmospheric friction. The dark void is simply light in its natural, invisible state while in transit. But even without an atmosphere to scatter things, shouldn't looking directly at billions of distant galaxies still result in a blinding wall of light? To understand this, we have to look at the motion of the cosmos. The physical fabric of the universe is rapidly stretching apart, carrying galaxies away from each other. As ancient starlight travels toward us, the expanding space physically elongates the light wave itself. This stretching transforms the light into the infrared spectrum, a wavelength human biology is incapable of seeing. Space is currently saturated with the light of billions of stars. We simply lack the sensory equipment to detect it. The darkness we see is a product of biological limits, where our eyes fail to process the infrared glow of an expanding universe. This leads to a common question. If space is black, why do astronauts see bright sunlight while operating outside their ships? While the sun itself is blinding, looking away from it reveals only blackness because the light beams have no particles to scatter against. The surface of the moon provides the ultimate proof of this phenomenon. At high noon on the moon, the sun-drenched ground is bright, yet the sky directly above remains pitch black. The moon lacks an atmosphere to catch and scatter the sun's rays, leaving the sky in its natural state. A glowing daytime is a planetary event, not a cosmic one. It is possible to stand in direct sunshine while staring into an ocean of darkness. Space remains dark because it lacks scattering particles, and cosmic expansion stretches starlight into wavelengths that fall outside our visible range. Our atmosphere is a rare privilege that gifts us a glowing daytime sky, a phenomenon that doesn't exist in the vacuum beyond. The dark void serves as a massive canvas, capturing the evidence of a universe that is constantly expanding and saturated with energy we cannot see. If this changed your perspective on the night sky, subscribe and comment the word space down below. See you in the next one.